Hey, my name's James Sanders. Welcome everyone to the AI Coffee Chats podcast. Today I'm talking with Claire. Hey, Claire.
Hi, good to see you.
Yeah, so Claire and I met when I was on the machine learning platforms team at Wayfair, and we both happen to be in the Denver area, which is really cool. And following along the coffee theme today, this is what I am drinking. My wife got me some awesome beans, so I'm not sure if I can pronounce all of that correctly, but anyway, I'll put a link to it in the show notes. Claire, what are you drinking?
Yeah, so you're gonna love this. I do have a pretty unique coffee drinking pattern. So what I do
Okay.
every morning is I get like my Starbucks, so I'll just get like a latte or something. But then throughout the day, and this is where my coffee addiction probably becomes apparent, I continue to just make black coffee and add it to the cup. So you're just like diluting the latte over time. This is in no way like a tasty delicious kind of coffee approach or approach to drinking coffee, but it is very efficient. So I'm like kind of keeping my latte refreshed throughout the day, just drinking from the Starbucks cup. So that has been my go-to recently.
Awesome, awesome. So, well, yeah, that sounds good to me. It'll keep you going, right?
It does. It's typically the caramel latte from Starbucks. That's
All
typically
right.
what I'm
There you go.
doing.
Claire's drink, caramel latte. If you're ever in Starbucks with her, that's what she drinks.
There you go.
So, hey, Claire, do you want to kick us off by giving us a bit of an intro about you and your background?
Yeah, absolutely. So, elevator pitch here. So, I come from a math background, which we're going to dig into a little bit today.
That's what it's all about
Um,
today. Math.
yeah, that's the theme. So I have bachelor's in applied math and then master's in statistics. I don't know why I did that to myself. I just was so excited about statistics, took a probability course and was like, oh, this really resonates and just continued on that path. But then I ended up working as a data scientist. Started as like a data analyst, moved into data science, doing like machine learning modeling, working in Python and R. And I did a couple gigs like that. I did a consulting gig. I did a really fun job at Trunk Club where I was working on like personalized styling and like fashion. So I got to apply math to that, which was really fun. And then I moved into the MLOps space, which is where I'm sitting now. So I moved more into the engineering side, like how do you actually operationalize these AI and ML models? So I led a few teams, like engineering teams, Twilio and Opendoor, and I'm currently at Arize AI, which is a MLOps tool. And that's actually how we met
Yeah.
when you were working at Wayfair there. So I'm very firm in the MLOps space right now. It's been kind of cool to kind of just grow with the AI space, like kind of going where the problems are from like figuring out how to model stuff to figure out how to get it into production.
Excellent. Well, I'm very glad to hear you've got all that math background because that's our topic for today. So, want to talk specifically around sort of data science, artificial intelligence, machine learning. So, when we're thinking about those spaces, what are the key branches of mathematics that sort of are key and feed into that space?
Yeah, so there's math in all these branches. And I'm really glad that I have the math background because it helps me stay a little bit up to date with all of these. Like if a new kind of deep learning model is created or a new tabular machine learning modeling approach, I can actually pick up a research paper and read those equations that are mostly written in Greek and actually try to like, it takes a few iterations, but I can understand kind of the theory behind these models, and that helps me figure out how they work and how to apply them. Um, so what kind of math is most relevant here? I think math is really boring until you get to calculus, and then calculus is actually going to be used a lot across this
Yeah.
stuff. Um, so some of those equations, things like area under the curve, like that general stuff from calculus is going to be relevant specifically for like metrics and optimization functions. And then the other side of it is going to be probability and statistics. And I think of those kind of lumped together because that's mostly like my education and my master's was kind of those together. But they really are kind of different functions. Statistics, like you're really kind of measuring a lot of metrics, making estimates, like hypothesis tests, that kind of stuff. Whereas probability is kind of like a beautiful language to describe the entire world. That's how I think of it. And that's definitely kind of my favorite branch there. But those kind of core concepts are going to be across every kind of area in machine learning and AI today. It's going to be in your deep learning. It's going to be in your more like tabular machine learning, like logistic regression, XGBoost, that kind of thing. And it's also in your Gen AI. Gen AI is actually very heavily like probabilistic based. So it's definitely a great kind of tool to be able to understand those kinds of concepts.
Excellent. All right. Well, look, let's jump into a couple of those. Let's dig into a couple. So, starting with probability, I mean that's an absolute core building block of machine learning. So, tell us a bit about probability and what role it plays.
Yeah, so you're right. It's kind of like the core of a lot of these models. When you look at the LLMs, like the Gen AI models these days, which are so popular, it's very core to that because those models are probabilistic. What they're essentially doing, and I know this is oversimplifying, but they're essentially predicting the most likely next word in a sequence. So you're doing the sequence modeling where you're actually just using probability to say like, if you look at a sentence where I say like my favorite color is, well, what's the most likely thing for me to say? And they'll look at context data around that. And based on the probability of the most likely next word, that's how it's actually constructing the output. So it's completely probabilistically based, which means that you can actually use that kind of theory, those equations to model the inputs and outputs of this and really kind of get like a deeper understanding of how these things are working under the hood.
Yep, cool. All right, another big one that you mentioned there was statistics, and I see statistics mentioned a lot of the time in the in these roles and in these jobs. So, how does stats fit in with machine learning?
Yeah, so that's a great question. When I started my career, I was working with statistics with very small data sets. And so we'd get like a hypothesis test where like maybe you have like 20 samples and that's your data set that you're running it on. That's a different world than like the big data AI ML where you're really like training a model across like millions of observations, things like that. But the statistics are still relevant. One use case that I can share as an example here is actually A/B testing. So let's say that you have two models, you got two machine learning models that you trained over billions of data points. And you want to know which model is better. So how do you figure that out? So there's actually that statistical approach of like just do an A/B test. You're doing a hypothesis test where you're really running a true experiment. It gets into that true like experimentation mind frame where like I'm going to run both of these models in production. I'm going to collect data samples from both, and then I'm going to look at accuracy metrics from each model. I'm going to do like a formal statistical test to measure how good each model is and compare them and actually get some confidence in that result. So it's a very like the thing I really like about the statistics applied to machine learning here is like it's very much of an experimental research mindset to approach things with where you are being scientifically accurate about the conclusions that you're making. It provides a framework for that.
Yeah, well, and it's almost like the science part of data science,
It's
maybe.
the science part of
It's
it, yeah.
basically applying the scientific method, to a business problem or a domain problem, and using statistics to draw inferences and and make decisions, which is where.
Exactly. Yeah, because I could just look at like a cooler modeling approach. Like let's say I have a logistic regression and I think deep learning is cooler. It kind of is, but that's not the right justification to go use it for my business case. I actually have to scientifically measure like is it producing inferences and predictions that are more valuable than my easier modeling approach that I started with to kind of justify the effort there.
Yeah, and I mean, this is a bit of a digression, but another thing that I've heard a number of times too is that basically the you have to take into consideration the complexity of the model and the complexity of maintaining a model over time. So it may not necessarily be the right thing to use the most complex model, even though it may produce the most accurate results. The right thing may be to actually pick a simpler model that's a bit less accurate, but it's a bit cheaper to run, potentially cheaper to train. So it's those trade-offs are interesting.
Those trade-offs are very interesting. It's something that I see the best people in the industry will always look at those trade-offs. So that's like a pro tip there is to make sure you look at that. Even if the model is more accurate overall, if it's going to cost you more money to produce inferences from it, then it would save you money to have more accurate predictions. That's something to look at. That's always the trade-off is like the cost, the complexity, even like time to deploy something, like how long is it going to take you to research and try a new modeling method and what gains can you expect from that? Like that's always kind of the framework that we have to think about these things when we try to project manage ourselves on these data science projects.
Yeah,
Yeah.
yeah. So getting back to the math side of things, quick shout out to my son Max, who's at the University of Washington doing calculus. He's probably in a calculus
Ah,
class as we speak right now.
that's
So,
fantastic.
let's assume he becomes amazing at calculus. How is he going to use calculus in machine learning?
Oh, this is a great question. I feel like, first of all, I'm glad he made it to calculus because that's when math gets fun. I feel like if you stop doing math when you're in like kind of the earlier phases with it, like maybe just like algebra, you're like, this is boring, and you might be right, at least from my perspective. Like that is the boring, like it's still valuable. But once you get to the more advanced stuff, it becomes a little bit more interesting just in terms of like the complexities and the applications as well. So once you get to calculus, I think it like opens up a world because it's also like foundational for some other kinds of math that'll build on top of that. But you're asking like, how is he going to use it in machine learning? So every machine learning model, AI model, data science model, whatever we want to call them these days, but any kind of just like mathematical model, they're actually just a mathematical representation of patterns we've learned from data. So like the big question is like, how do I get value from this data? A business wants to get value from their large data sets. The way AI does this, or ML, is it will look at that data, that's the training phase, and then it will encode the patterns that it learned mathematically and store them. And then when you need to make a prediction, it can rely on those patterns. And that's, I think, a good way to kind of look at this is you're essentially just like making a mathematical representation, somewhat of a generalization of the data that you have. And then you're able to use that to very quickly like make predictions, make inferences, identify future trends that might happen. So calculus is just foundational for that. There's a couple things that are going to be relevant there. One thing that comes up is like gradient descent, I think was something that was covered in my calculus class. Like that's how these models are even created in the first place. It's kind of this like iterative algorithm that will converge to an optimal solution. And that is incredibly useful because what that does is it is forcing these models to learn the optimal solution off of the data. And then that's what's used for like future accurate predictions. So core concepts like that, like it's just foundational. You might not see it today of like, oh, I could apply this to a machine learning model that like optimizes purchases for a retail company, or maybe they're trying to use computer vision to identify like damage on a car. There's like so many cool use cases that you just don't think of when you're in the class, but it's so general that it can really be applied to like every area that you're interested in. And that's something I recommend to people is like, if you're passionate about something, like maybe you're passionate about cars or fashion, there's going to be application areas in those fields that you may not be aware of. But they're actually quite powerful. So it's kind of a cool kind of convergence of use cases there.
Yeah, yeah. The other one that I hear all the time and gets used all the time, and NumPy seems to get used a lot in this area is the linear algebra branch. So tell us
Oh
about
yeah.
like why we use linear algebra.
Yeah, I had two courses on this one. There was linear algebra, and then there was something called like matrix factorization. I couldn't believe there's an entire course on this, but now looking back, like it makes so much sense. Essentially, when you're working with a large data set, it is a large table of data. And so we need ways to do mathematical operations on top of that, ways to interact with it in the models. And I think that's what linear algebra is really boiling this down to. One concept that pops out in my mind is embeddings. I remember studying PCA, principal component analysis. I think that was in linear algebra. Maybe it was covered in calculus too, but it's essentially like extracting meaningful patterns from very large data sets and representing them mathematically. So I think that's a relevant one there. Embeddings are like a core concept that's across machine learning all the time right now. And I think from looking at things in kind of like a matrix form in linear algebra, you'll get kind of a sense for that.
Yeah, and I think that's one of the reasons, of course, why all the GPUs and NVIDIA chips and everything are so critical, right? And why they're going gangbusters because they're the things that do those billions and billions of massive matrix, multiplications and linear algebra. So, yeah, shout out to linear algebra. That's
Yeah,
where
shout out to linear
bunch of
algebra.
a bunch of the grunt work gets done, right?
Absolutely. Another thing that comes to mind that's very important right now with LLMs is people are building these RAG systems, the retrieval augmented generation, where they're trying to like find relevant information in a set of documentation. That is also linear algebra because all you're doing is like some kind of dot product cosine similarity between like vector embeddings. And I know that sounds like super technical, but essentially what you're doing is you're taking words, you're essentially converting it to linear algebra, where you just have like, it's a matrix of numbers now, and then you're finding similarities in that matrix. And that's actually what is like driving a lot of like chat bots today, which is pretty wild.
Yeah, yeah, very cool. Now, a lot of this math that we're talking about here, a lot of it is embedded in machine learning libraries like, PyTorch, TensorFlow, scikit-learn, that you can use to build, train models, do inference, all that sort of good stuff. So why do we need all this math, Claire? I mean, it's hard.
Yeah, it is hard. That's a very good question. You're right. I think a lot of the tools that we have today will abstract the math away from you. You can import scikit-learn and train a machine learning model in seconds, and that's awesome. That's extremely powerful, and we should all be using those tools. However, the reason that I'm glad that I have the math background here, and I do think that it can be very helpful and kind of an edge for people in this field, is that by understanding theoretically the mathematical construct of these models, the nuances like whether it's a linear or nonlinear relationship in the model, those kinds of mathematical concepts will help you choose the right model for the use case. And the counter to that would be like, well, I can just do a hyperparameter search. You can, it's expensive, go for it. That will also solve the same problem. But on top of that, the challenge right now in AI is there are new things coming out weekly. There's new papers on like LLMs and RAGs and like different like reinforcement learning techniques that are coming out every week. And if we're not able to pick up a research paper, read it, understand it, and have some kind of like mathematical intuition on like what the shortcomings of the method might be, where they might be appropriate to apply them versus not, we're going to be very blocked in terms of our growth in the industry. So being able to just like have that math background, even though like, yes, I think technology will get so advanced that like I can just with a few clicks of a button, build a RAG system and not worry about the math behind it. But what are the weak points of that system? What kind of complex evaluation metrics can I make up to protect against that? And having that intuition will help you design the systems as well as just like stay on top of the new stuff because it's coming out all the time.
Yeah, yeah. I mean, another one that jumps out to me that's been very helpful is when you're trying to explain a model or how a model works to a layperson, like a stakeholder or something. I mean, not that you'd actually go into the detail with them of the math, right? That's not what I'm saying. What I'm saying is if you actually understand the math of how the model works, then that empowers you to explain to them in more straightforward terms. I think it makes a big difference if you actually understand how under the covers, or how it's all
I think
working.
so. I think so. Yeah, I've explained embeddings to many non-technical stakeholders that I even have ended up with just an elevator pitch for it. And it clicks. Like if you can boil down a more complex mathematical topic and actually like deliver that to a non-technical stakeholder or a customer, that can be kind of a really powerful career edge as well.
Yeah, yeah. And one other that I've found helpful to know the math is when you're troubleshooting a problem. Quite often, or there's a piece of data that comes along that sort of tricks out your model or something. It can really expedite that process if you actually
Yep.
understand under the covers what's going on. Otherwise, it could take you it may take you a lot longer to work out what's going on.
Yeah, so it can kind of help in that like feature engineering step as well as like debugging, like something went wrong with my model. How do I kind of root cause that?
Yeah, yeah. So, all right. So, speaking of math again, I'm just curious. I mean, I don't want you to name any names here, but have you got any good stories you can tell us about situations where that you've come across where people you're working with obviously just don't get the math?
It's a good question. Yeah, through my whole career, I've gotten kind of some like attitude, I guess, from people because I do know the math, and that's been interesting to encounter. Early in my career, like when I told people what I did, like maybe I'm meeting a new person and it's like, oh, what do you do for work? What did you study in school? I would say like, oh, I studied math or I work as a data scientist. And I would get the same response often. They would be like, oh, that sucks. That sounds really hard. I'm not good at math. Like just kind of this like immediate like, oh, that sounds so terrible, which was kind of interesting because for me, it's like, I think math is like a beautiful kind of creative puzzle and it's really fun to work in that space. And if they were like, working in a different space like biology, for example. And I don't love biology. I think it's a lot of memorization. But if someone tells me they're doing that, I'm gonna be like, oh, that's cool. Like, not like, oh, that sounds so hard and I hate that. So that was kind of an interesting like response, but I think it like indicates to me that there's a little bit of like a fear of mathematics that I think actually happens at a younger age, maybe like high school, earlier, where we just look at this and we just think it's hard. I don't know exactly the root of that, but like a lot of things in life are hard. Other subjects we could study are hard. I think that this one is still very valuable. And I want to get to a point where it's like we have more of like a curious response instead of like, oh, that sounds like, I don't know. I think it's something about like maybe the earlier mathematics that we study are not enjoyable until you get more to like the calculus level. It's kind of a different world. So I think there's a little bit just like a stigma, I think, around mathematics, which I see for sure.
Yeah, yeah. No, you see it everywhere. And I
Yeah.
wonder if it's something that parents sort of push down too, like parents who found math difficult or whatever, sort of push that negative attitude.
Sure. They don't want to have to do it again.
Yeah, that's right. Oh, I can't help you with that. Sorry.
Yeah.
That's
Let's
just
help you with your other homework. Yeah,
yeah.
I think there's probably some of that too. I think there's also like a general unawareness of like what you can do with it. Like another thing people would say to me, I would tell them I'm majoring in math, and they were saying like, oh, what can you even do with that? All you could really do is teach. Like you would just have to continue in academia. That is one path, but there are so many more. Like you could pivot to be a software engineer, you could be a data scientist, data analyst, you could move into economics. There's just an incredible breadth of like
Yeah.
applications for it, but you do have to find a way to actually apply it. Yeah,
Yeah. I mean, I know it's geeky, but I mean, it's the language of nature, right? Like,
it is.
it's incredible what you can do and what you can describe with it. But that's me just getting a bit carried away.
I agree with that. I think it's a language that you can use to actually describe the world, like represent the world. That's why we can do like simulations of things at high levels of complexity.
Yeah. Well, hey, simulations. That might be another good podcast sometime. That's
Oh, that
another
would be great.
we could jump into.
Are we living in a simulation? I want to hear that podcast.
Do the Matrix.
Yeah.
All right. So what about in your personal life? So, you love math, obviously. So have you ever used it, or how do you use it in your personal life?
Yeah, I do. So that is a great question because I don't use it in the way that you might expect. I think a lot of people with math backgrounds will just approach life in a way that they're just like trying to optimize everything, like just have a metric for everything. Maybe you got a spreadsheet for everything. You're trying to optimize stuff. I actually don't do that. I do
Oh,
enough of that at work. So I try to, in my personal life, stay creative and think a little bit more on that side of my brain. But the way I use math in my personal life is actually quite funny. I play a lot of poker and I realize like I can't believe that game exists. Like it's just so amazing. It's literally just like a mathematical representation, almost like a simulation of like a contained environment. It can be perfectly mathematically modeled to some extent, maybe not solved. But it's just equations. Like, so when I realized that like, oh, I could actually just like play poker and I could just be thinking about like mathematical equations in my head, I was like, this is awesome. This is a little too good to be true. So I picked that up as a hobby, just as a way to kind of like exercise the mathematics. And the cool thing about it is like I'll be studying like kind of like the probability behind poker, which is kind of more simple probability. It's like pot odds, equity calculations, expected value. That's a concept that comes in a lot. And it's actually translating to my work because when you look at like the architecture of an LLM, that's probabilistic as well. Things like expected value matter when you're calculating metrics. So it's actually got some like great crossover with like the world of AI, but it's kind of just like a fun environment to practice it. Yeah.
yeah, yeah. So when you're thinking or about the math in poker, I mean, what are you practically doing? Are you just doing everything in your brain, or do you have a notepad and paper, or do you have I don't know, Python notebook open, or what do you what do you
I've
do?
got everything. That's a great question. So, some of the poker calculations are not really possible for a human to do like on the fly at the poker table. But what I found is like being able to map the poker scenarios to a mathematical framework helps me almost like visualize more of a long-term strategy. So even though like I'm not probably going to do like a complex expected value calculation at the table and be accurate, I can estimate it pretty quickly. And when you layer like experience in onto that, you can do like some simpler calculations, some like estimations, some kind of hacks there. So you can keep that kind of like approach to like doing the math while you play, but you're not doing like the hard math, I guess would be a way to say that. And then
Yeah.
beyond that, I did model it in Python. I am working on like a reinforcement learning algorithm that's actually going to like play poker. And that just forced me to like write out the math and the equations of this entire environment, which helps me just like put it in a framework. So it gives me like a framework to think and like analyze stuff. I can go back and like analyze one play that I made slowly, but at the table, I'm not going to be that fast.
Yeah.
Robot would be better at that, but we're not there yet.
Have
Yeah,
you got have you got Claire Bot playing for you yet or not?
not yet.
No.
Not yet. No, she's still active on Instagram.
Yeah.
She's
Okay.
not writing any of my emails yet and not playing poker for me. So I haven't been able to fully automate.
Yeah. All
Yeah.
right. So for those for those of us who want to get a bit more into the math, what options are there for people interested in, AI, ML, data science? What options are there for them to get the qualifications and the knowledge that they need?
Yeah, so I think there's the foundational math first. So that's going to be like your calculus, your probability, your stats, and your linear algebra. You can get that from online courses. You can get it from school. If you don't have it in school, there's nothing stopping you from like going back and filling those gaps with like online material. So I think anyone could dive in and do that. And then on top of that, to like more apply it to like AI machine learning. I love like Coursera courses, that kind of thing, just to kind of go through the math of these different like machine learning models and kind of map that out that way.
Yeah, yeah. Now there are actually some interesting ones on for the online variety. They've actually got, specifically math and machine learning in the title. I think the one, and I'll put the link to this one, the one I'm thinking about in the show notes. But it's like a 12, 14-week course or something, and specifically, math for, for machine learning. So
Oh,
uh,
that's perfect. Yeah, that would be the kind of course I recommend for people. Because if you come at it from a mathematical framework, I think it's going to help you kind of deeply understand the different machine learning methods there.
yeah, yeah. Well, and I think also one of the things you said to me before too is that one of the great things about math is how transferable it is, right? It's just it's really easy to apply into other parts of your life or your career.
Absolutely. Yeah.
Yeah. So looking ahead, let's put our crystal ball, I don't know, propeller head hats on or whatever. When we're looking at some of the AI and ML developments and technologies that are emerging right now, there's so many. As you said, it's pretty tough
Yeah.
to keep up with all of it. But are there any that you've seen recently that are sort of starting to emerge now that you think are going to have a big impact over the next few years?
I do. Yeah. So LLMs are obviously big. Um, I'll say something controversial. I don't think they're as big as we think they are. I think there's going to be different models that come out or slightly different LM approaches that make the LM world as big as we think it is now, if that makes sense. So I think right now LMs are very good at language tasks. It's a language model. If you're creating a chatbot, if you are trying to do like text summarization, something like that, these systems are out of this world incredible at that, like a step change from what we've seen in the past. So there's some pretty amazing use cases they're going to solve. They're not good at math yet. They are good at pattern recognition within text, which is valuable. But the thing that you get from like tabular machine learning is that you can directly optimize a metric. Like I can say, I want to optimize the click rate on this product recommendation. And then you can actually force your algorithm to look at the data and directly optimize that. A language model is not doing that. So I think that there's going to be some advancements in terms of how we layer in like multimodal, reinforcement learning can do this. There's the reinforcement learning human feedback kind of approach in the LMs. I think there's going to be research in that area, that anything that's going to allow us to work with these more generative AI systems and help them actually do like direct calculations and true like numeric calculations. I think that's where we're going to start to really unlock the power of this, because then these systems could start to replace some more traditional use cases, like maybe like a time series forecasting or a recommender system, things like that. Right now, I think we're kind of tinkering with a tool that can kind of do some of that, but it's got some limitations in the sense it's very good at language and not as fluent in math yet. One thing that also like I really want to experiment with is like fine tuning these things on mathematical like papers. Like if you just feed a bunch of math papers into this thing, you can teach it math and they'll know it in a language construct. But I think like research like that is very interesting to me right now. I think that's kind of where things should be heading.
Yep, yep. One other one I'll mention that's sort of getting me pretty excited now. I've been reading quite a bit about is the agent based solutions now, and the idea of a master agent being able to fire up a bunch of little sub agents doing different tasks and being able to connect into the real world and do tasks. They
Yeah,
put together a plan of what it is that they're going to do. You can adjust the plan, and it'll go off and do all the work. I think there's some really interesting possibilities there in terms of more complex behavior and planning, and longer transaction,
I
longer
think
run
so.
processes. So uh,
Yeah.
that's really interesting to me.
Oh, me too. Yeah, that's very exciting. I think it's a little scary too, because it's like these things are actually going to go out there and take action and do things. But there's something about like human in the loop AI, which is the way I like to think about it. Like if you can always interact with these systems, steer
Yeah,
them, override them, then this can be a very safe kind of
yeah,
infrastructure for that. Yeah.
yeah, yeah. Well, I mean, if you think about the massive investment that there's been recently in APIs, right? Well, there's an API for everything, right? Which are all basically ripe for agents to be going and doing stuff. So very interesting. But yeah,
Yep.
let
Yep.
me.
I haven't gotten my tools that far. Like I have a couple personal projects that I've not reached that level of automation, but I could visualize how to do it. Like you could get
Yeah,
things to post on Instagram for you automatically, stuff like that.
yeah. So what is there anything else I should have asked you that I didn't ask you?
No, these were all great questions. I think it covered things really well. I think like the last thing I would say to people is don't be afraid of math. It's actually really fun. And I think one blocker that I had with math when I first started working with it is I would just like sit down to do my homework and just be like, this is really hard. And it was a little bit of like an attitude problem. And as soon as I reframed it of like, oh, this is like a fun, beautiful puzzle that's going to be useful and start looking for like fun applications for it, it became really enjoyable and kind of fun to work with. So that's a recommendation I have to people who are maybe just starting out with it. Like, don't be afraid of it. If you look at it as just kind of like a fun puzzle, that can be kind of a better way to approach it.
All right. Well, thanks, Claire, for joining me today. Thank you for sharing your insights on math in artificial intelligence and machine learning. And thanks everyone else for joining us on the AI Coffee Chats podcast. And we will catch you next time.
Yeah, thank you. Good to see you again.